Hello my dear students, I heartily welcome you all for the Samveda e-learning program. Today you are going to learn more about 12th chapter sound. In the previous session you have learnt about production of sound, how do the sound propagate from one place to another place, and you have learnt that sound need a material medium to travel by conducting Bell-jar experiment, and also you have learnt that the sound waves are longitudinal waves, and you have differentiated between longitudinal wave and transverse wave, and also you have learnt that how the crest and trough is going to be formed in case of transverse wave, and compression and rarefaction is going to be formed in case of longitudinal waves. Today you are going to learn about characteristics of sound wave, speed of sound in different medium, reflection of sound, and the formation of echo as well as reverberation. Let us learn all these things one by one. Are you ready with the pen and the book to make a note of the important aspects of this lesson? Let us learn characteristics of a sound wave. A sound wave can be described by its amplitude, time period, wavelength, and frequency as well as speed of the wave. So, we have to understand the meaning of amplitude, time period, wavelength, the frequency and speed to understand about sound waves. What is an amplitude? An amplitude is nothing but the maximum displacement of the vibrating particle from its mean position. As you all know that the vibrations of the medium can produce the sound. So, where in case of the vibration there is a displacement of the particle of the medium. So, that maximum displacement of the particle is called as amplitude. Here you can see the maximum displacement with the help of this image, that is what we call the amplitude. Now, let us learn what is wavelength. Wavelength is nothing but the distance between two consecutive compressions or two consecutive rarefaction in case of longitudinal wave, and it is going to be represented by the symbol called lambda, and SI unit of wavelength is meter. The wavelength in case of transverse wave, it is the distance between two crest as well as two troughs. Now, let us learn about frequency. Frequency is nothing but the number of oscillations per unit time is the frequency of the sound wave. You know that vibrating particle can produce sound, that vibrating particle can move in the form of longitudinal wave. The oscillations per unit time, the formation of crest or trough in unit time is called as its frequency. If we can count the number of compressions or rarefaction that cross per unit time, we will get a frequency of the sound wave. It is usually represented by the letter nu, and its SI unit is hertz. So, the symbol is Hz. Can you repeat again what is the frequency? Yes, the number of oscillations per unit time is called as frequency of the sound wave. Now, what is time period of the wave? The time taken by two consecutive compressions or rarefactions to cross a fixed point, which is called as time period of the wave. Time period of the wave, it is going to be represented by the symbol T, SI unit of the time period. It is second, and the relationship between the frequency and the time period is frequency is equal to 1 over time period, or reciprocal of the time will be the frequency of the sound wave. Now, let us learn about pitch. What happens when violin or flute is going to be played? A violin and a flute maybe both are played at the same time in an orchestra. Both sounds travel through the same medium, that is air and arrive at our ear at the same time, but both sound travel at the same speed irrespective of the source, but the sounds we receive are different. This is due to the different characteristic associated with the sound. This is what we called pitch. Pitch is also one of the characteristics of sound, enable us to differentiate the sounds of the different objects. We can hear and we can identify the different instrument is going to be played in orchestra because of the characteristics of the sound, that is what we call pitch. So, what is a pitch? Pitch is nothing but how the brain interprets the frequency of emitted sound. It is called as pitch. So, it is going to be differentiated by or interpreted by our brain. What happens if the faster the vibration? The faster the vibration of the source, the higher its frequency and higher is the pitch. If the sound wave travel faster, what happens? Its frequency is having high and its pitch also becomes higher. A pitch sound corresponds to the more number of compressions and rarefactions passing a fixed point per unit time. If there are more number of compression and rarefactions are going to be crossed a fixed point, that gives the pitch. If there are less number of compression and rarefaction means lesser the pitch, and there are more number means higher the pitch. The object of different size and conditions vibrates at different frequencies to produce sound on different pitch. This is you have to know. That is why we could able to identify the different instrument is going to be played at the orchestra. What about loudness and softness of the sound? Sometime we say that the sound is louder, sometime we say that sound is very soft and very pleasant to hear. The loudness or softness of a sound is determined by its amplitude. Here, amplitude decides the loudness or softness of a sound, but in case of pitch, frequency decides the pitch and amplitude decides the loudness or softness of a sound. The amplitude of a sound depends upon the force with which an object is made to vibrate. If we strike a table lightly, we hear a soft sound because we produce a sound wave of low energy or with low amplitude. So, similarly, if you are going to beat the table at the high force, louder sound is going to be here. That means, we are going to increase the amplitude of the sound. That is why we could hear the loudness. Loud sound can travel a longer distance when compared to the soft sound, as it is associated with the high energy. A sound wave spread out for its source, as it moves away from the source, its amplitude as well as its loudness decreases. We can hear the more sound near the sound producing object, but as we move away from the sound producing object, we are going to hear a feeble sound or a less sound, because the energy as well as amplitude is going to be decreases as one move away from the sound producing point. Now, quality of the sound. To listen the music or to hear the sound, the quality of sound displays very important role. The quality or timbre of a sound is that characteristics with which enable us to distinguish one sound from other having the same pitch or loudness. The sound which is more pleasant is said to be rich in quality. Tone, note and noise with respect to the sound or music. A sound of single frequency is called as tone. For example, flute sound and violin sound and guitar sound, veena sound, etc. are example for the tone, because they are having single frequency. Then what is a note? The sound which produced due to a mixture of several frequencies is called as note. If the different instruments are going to be played at the same place like orchestra, there we can find the note, because the sound which is produced due to a mixture of several frequencies, and it is pleasant to listen to. You know that noise is unpleasant to ear, the music is pleasant to ear, is of rich quality, it is already you learnt. Now, let us learn intensity of sound. The amount of sound energy is passing in each second through unit area is called as intensity of sound. If the more intensity means more sound energy is passing, if the intensity is less means less sound energy is passing in each second through a unit area. We sometimes use the term called loudness and intensity interchangeably, but they are not the same, they are different. Then let us learn what is loudness. Loudness is a measure of response of the ear to the sound. The loudness is going to be measured by the response of the ear of the sound. Loudness is going to be measured with respect to the response of the ear to the sound. Even when two sounds are equal intensity, we may hear one as louder than the other simply because of our ear detected better. Now, let us learn about the speed of the sound. The speed of the sound is defined as the distance which a point on a wave, such as a compression or a rarefaction, travels per unit time. That is nothing but it indicates how faster the sound is traveling from one point to the another point or from one place to the another place. The speed is going to be calculated by using distance travelled by the sound wave with respect to the time, that is V is equal to distance by time. Let us solve a problem related to the speed of the sound. A question is like this: a sound wave has a frequency of 2 kilohertz and wavelength 35 centimeters. How long will it take to travel 1.5 kilometers? Let us write the data which is given in the question. The frequency given 2 kilohertz, which is equal to 2000 hertz, wavelength 35 centimeter, which is given, it is equal to 0.35 meter, because wavelength is going to be represented by meter. We know that the speed of the wave is equal to wavelength into frequency. It is the product of wavelength and frequency. Multiply 0.35 into 2000, you will get 700 meters. That is the speed of the wave. Now, to calculate the time, so we have to use the formula T is equal to d by V. Distance travelled is 1.5 kilometer, convert that one to meter, you will get 1.5 into 1000 divided by velocity of the sound 700 meter per second. You can cancel 2 zeros in both numerator and denominator, finally you will get 15 by 7. After the simplification you will get 2.1 second. So, that gives the sound will take 2.1 second to travel a distance of 1.5 kilometers. Is it understood? Yes, it is very easier to calculate. Now, let us go to the next concept, speed of the sound in different medium. My dears, you should know that the speed is not same in all medium. It is different in different medium. The speed is, I told you already, the speed is more in case of solid. The speed of a sound in a medium depends upon the temperature of the medium. That is the important thing you have to note. The speed of the sound wave decreases when we go from solid to gaseous state. In many medium, as we increase the temperature, the speed of the sound increases. As the temperature increases, its speed is also increases. For example, the speed of the sound in air is 330 meter per second at 0 degree Celsius and 344 meter per second at 22 degrees Celsius. The speed of the sound at a particular temperature in various medium are listed in the table 12.1 in your textbook, and you need not to memorize the value, just you can go through it. Now let us learn about the reflection of sound. Like light, sound is also going to be bounces from the solid surface or liquid like rubber ball bounces of a wall. Just like a light, sound also exhibit the property of reflection. Sound get reflected at the surface of a solid or liquid and follows the same law of reflection as you have learnt in the earlier classes in the chapter light. The direction in which sound is incident and it is reflected make equal angle with the normal which is drawn at the reflecting surface at the point of incidence, and the three are all lie on the same plane, and this is how the reflection of sound is going to be takes place. When the sound is going to be incident on a wall or a surface, then it is going to be reflected, and when we are going to draw at the point of incident, we will get angle of incident to the angle of reflection, both gives the same value, and the incident sound wave, the normal as well as the reflected sound wave, the three are lie on the same plane. To verify this, you can conduct an activity. For this, you have to take two identical pipes. You can make the pipe using chart paper. The length of the pipe should be sufficiently long as shown in the figure. Arrange them on the table near a wall. Keep a clock near the open end of one end of the pipe and try to hear the sound of the clock through another pipe. Adjust the position of the pipe so that you can best hear the sound of the clock. Now, measure the angle of incidence and reflection and see the relationship between the angles. Lift the pipe on the right vertically to a small height and observe what happens. So, like this you can set up the experiment to verify the reflection of sound with the help of two pipes. Now, let us understand what is an echo. What happens if we shout or clap near a suitable reflecting object such as tall building or a mountain? Yes, we will hear the same sound again a little later. This is what we call echo. The sound which is after the reflection is called an echo. The sensation of sound persists in our brain for about 0.1 second. To hear a distinct echo, the time interval between the original sound and reflected sound must be at least 0.1 second. So, if we take the speed of the sound is 344 meter per second at given temperature, say about 22 degrees Celsius in air, and the sound must be go to the obstacle and reach back the ear of the listener on the reflection after 0.1 second. Hence, the total distance covered by the sound from the point of generation to the reflecting surface and back should be at least 344 into 0.1, which is equal to 34.4 meters. That means, it is the time lapse between the sound which is produced by the listener and to hear the reflected sound back. Thus, for hearing distinct echoes, the minimum distance should be half of the given length. That is, the obstacle from the source must be half of the distance, that is 17.2 meters. This distance will change with the temperature of air. Echoes may be heard more than once due to the successive or multiple reflections. So, we are hearing a rolling thunder during rainy season because of the successive reflection by the cloud as well as land. Now, let us solve a problem related to the echo. Question is like this: a person clapped his hand near a cliff and heard the echo after 5 seconds. What is the distance of the cliff from the person if the speed of the sound is taken as 346 meter per second? So, the data is given, the speed of the sound 346 meter per second is given, time taken to hear an echo is given, that is 5 seconds. So, what is distance travelled by the sound, which is equal to velocity of sound into time, d is equal to v into t, multiply 346 with respect to 5, you will get 1730 meter in 5 seconds. Sound has to travel twice the distance between the cliff and the person, hence we have to get the half of the distance. So, the distance between the cliff and the person will be equal to 1730 meter divided by 2, which is equal to 865 meters. That is the distance between the cliff and the person. There is another phenomena called reverberation due to the reflection of sound. A sound created in a big hall will persist by repeated reflection from the wall until it reduced to a value where it is no longer audible. What is reverberation? The sound created in a big hall will persist by repeated reflection from the walls until it is reduced to a value where it is no longer audible. Thus, the repeated reflection that result in this persistence of sound is called as reverberation. It is due to the multiple reflection of the sound. In an auditorium or a big hall, excessive reverberation is highly undesirable. Why? Because of multiple reflection. The seat material are also selected on the basis of the sound absorbing properties. To reduce the reverberation or the effect caused by the reverberation, the seat materials are selected on the basis of the sound absorbing properties. And also to reduce reverberation, the roof and wall of the auditorium are generally covered with sound absorbent material like compressed fiber board, rough plaster. These are the materials used to reduce the reverberation of the hall. My dears, you have learned many things in this session regarding the sound. So, let us recall what we have learnt in this session. You have learnt about time period of the wave. It is nothing but time taken by two consecutive compressions or rarefraction to cross a fixed point, and the symbol is used to represent time period is T, capital T, and its unit SI unit is second, and relationship between time period and the frequency is, yes, frequency is equal to reciprocal of the time period. Now, what is the frequency? Yes, you learned that number of oscillations per unit time is the frequency of the sound wave. It is represented by SI unit called hertz, and Hz symbol is going to represent the frequency. Similarly, I learnt about pitch. Pitch is nothing but how the brain interprets the frequency of an emitted sound is called as pitch. And also I have learnt about loudness and softness of a sound. It is depends upon amplitude, more the amplitude, more the loudness, less the amplitude, less the or softness of the sound. The loud sound can travel for the long distance when compared to the soft sound. The quality or timbre of the sound is that characteristics which enable us to distinguish one sound from the another having the same pitch or sound. And also I have learnt about tone, note and noise. If the sound having single frequency is called as tone, if it is a mixture of several frequencies, nothing but note. The noise is nothing but unpleasant sound that we can hear is called as noise. And also I have learnt about intensity of sound. Intensity of sounds depends upon the passing of sound through a unit area is called as intensity of sound. And also I have learnt about loudness. Loudness is the measure of response of the ear to the sound. Even when two sounds are of same intensity, we may be hear one as louder than the other. And also I have learnt about speed of the sound. Speed of the sound is nothing but the distance which a point on a wave such as compressions or rarefactions travel per unit time. So, we use the formula speed is equal to distance by time to calculate the speed. You have learned that speed travels different in different medium, it travels more in solid medium when compared to liquid as well as air medium. You have learnt about reflection of sound, just like light, sound is also undergo reflection, it follows the laws of reflection of light, and we can hear the echo when we are going to stand at a particular distance in front of the height wall or a cliff. You know that distance decides the formation of echo along with the sound. You know that reverberation is one of the cause of the reflection of sound. It is going to be reduced by using sound absorbing materials in the cinema hall or the auditorium. Now, my dears, take few questions based on today's concept. I request you to note the question in your book and get the answer and show to your teacher. The first question is, define wavelength, time period and frequency of sound wave. I will repeat again, define wavelength, time period and frequency of sound wave. Second question is, what is pitch of a sound? What is pitch of a sound wave? What is speed of the sound? Write the formula used to calculate the speed of the sound. Next question is, collect the information about whispering gallery of Gol Gumbaz which is related to the echo formation. Collect the information about whispering gallery of Gol Gumbaz. Fifth question is, what is reverberation? How it can be reduced? Fifth question is, what is reverberation? How it can be reduced? And the sixth question and the last question is, collect the information on auditorium acoustics. Collect the information on auditorium acoustics. These are few questions to write the answer. I hope you are all able to write the answer for this question. My dears, let us meet on the next class to learn more about the sound. Till then, have a good time, stay safe, keep learning. Thank you all.